This next system of inequalities are also going to be represented graphically with straight lines. They're both linear inequalities. And so I want each of them in the form y equals mx plus b. So I want them to look like y equals mx plus b in order for me to get a good sketch drawing this by hand. So the top inequality, let's write that as x plus 4y. We'll leave the less than or equal to 8 in this case. We'll leave it here and you can decide which technique you like better. So if I were to move the x to the other side, I would get 4y is less than or equal to negative x plus 8. Divide everything by 4. So y is less than or equal to negative 1/4 x plus 2. All right, this tells us that the y-intercept is at 2, positive 2, and that the slope is negative 1/4. So down 1 and to the right 4. Put a point there and connect them with a straight line, a solid line, because there is an equal sign underneath the less than sign. I'm having a hard time deciding how best to draw this. Let's go like this. Okay, I really need a ruler. Now the second inequality, I'm going to once again rearrange the pieces the same way I just did. I want that y to be by itself. I get 4y is greater than or equal to negative x plus 4. Divide everything by the 4. So greater than negative 1/4 x plus 1. Now, I don't know if you noticed this, but in this case I have the same slope. The slopes are the same. Slopes are the same. The y-intercepts are different. Okay? Because you have the same slopes but different y-intercepts, you are going to have parallel lines. The other line is going to be parallel. Let's see if I can do this. Oh, that's so bad. Okay, you get the idea? Parallel lines are not going to cross because they have the same slopes but different y-intercept locations. We need to decide where to shade, right? Are we going to shade in between those two lines, or are we going to shade on the opposite ends, above and below, above the top and below the bottom line? So you're going to choose your test point just like we've done in the past, and you're going to decide the appropriate region to shade. I'm going to choose the point 0, 0, right? So I plug 0, 0 into the equation or the inequality that hit at 2. That was the first inequality that I graphed. So if I plug 0, 0 in for x and y, I end up getting, I get 0 plus 0 is less than or equal to, oh, I do not get that. I get 0 plus 4 times 2 is 8 is less than or equal to 8. Is that true or false? Oh, you know what? I had it right the first time. It is a 0. Sorry about that. I forgot to use the origin. 0 plus 0. Is 0 less than 8? Yes, it is. So for the top inequality, you want to shade below. Okay, put on some little arrows here so you get a feel for the direction of the shading. Now use the bottom inequality in the same ordered pair, 0, 0. Gets substituted in for the x and the y. See if I can do it without messing it up this time. And you get 0 plus 0 is greater than or equal to 4. Is that true or false? Is 0 greater than 4? Well, this first one we said was true, but this one, the next one, is false. 0 is not bigger than 4. And so I want to shade the opposite side, right? I don't want to include 0, 0. I don't want to go below. I want to go above that second inequality. And so the actual solution set is going to be all of the points that are in between the two lines, because that was the region that was shaded by both pieces, the points in between. So all of the ordered pairs that lie in between those two straight lines are going to satisfy your inequalities. 34. All right, we've got linear inequalities again. We have linear inequalities. I'm going to rearrange the pieces. Y is greater than or equal to negative 2 for the first one. X, I forgot my x. Y is greater than or equal to negative 2x plus 2 for the next one. I again have the same slopes. So I'm going to have parallel lines, but they have different y-intercepts, 0 versus 2, and that means they are going to be parallel as opposed to being the same line. If everything's the same, it's just the same line. So the top inequality is going to hit at the origin and has a negative 2 slope. And so there's another point going down 2 into the right 1. And let's put a point here, maybe, just give us an idea. A solid line gets you this line here. And the second inequality hits the y-axis at +2 and also has -2 slope. So those are some points that this line needs to hit. Now we need to decide about the shading. So the thing about your test point is you cannot pick the point if the line went through the point. So 0, 0, not the best idea. Let's pick something more like maybe that one. Okay, that's the ordered pair 2, 0, 2 for x, 0 for y. Let's see what happens. In the top inequality, 2 times 2 plus 0 is greater than or equal to 0. Is that true or false? Let's see. 4. Is 4 plus 0 bigger than or equal to 0? I do believe it is. That one is true. So for the line that hit the origin, I want to include that test point, which means I got to go that way with my shading. Shade that way. Shade that way. That way. Okay. The second inequality, let's plug in the same test point. You don't have to use the same test point, but you can if you want to. So 2 times, let's do consistency here. Let's do 2 times 2 plus 0. Is that greater than or equal to 2? So now we have 2. One second. We have 4. 4 plus 0 is 4. Is 4 bigger than or equal to 2? Yes, that is still true. Therefore, for that second inequality, I want to shade the part that included the 2, 0 test points. All right. So now you got to decide where the overall common shaded region is. I want the region that was shaded by both lines. This region is going to make both inequalities happy, and that's going to be the part that is above that line right there. So everything out there is going to make that inequality true, both inequalities at the same time. Everything in that green shaded region will satisfy the entire system.